OSGI president, and I want to thank you all for being here. This is our 7th year in a row with doing this joint conference with the EclipseCon Europe, and it's been a wonderful experience. And I just can't believe it's 7 years already. This is a big milestone year for the OSGI Alliance. It's our 20th anniversary. We were founded in March of 1999, and we're really proud to what we've accomplished over that 20 years and taking a look back and looking forward. I don't want anything on the screen. That was intentional. Okay? Yeah, we'll take care of that in a moment, right? I got to switch around here. Ralph, where'd you put the plug? Okay. So, where was I? So we've done a lot of things. The original OSGI core framework and bundles and modules that ran on it still run today, and yet there's a much richer environment than there has ever been. Our member teams are what are, our members and their teams are what keep OSGI going forward. Tremendous amount of effort has gone into this. If you've taken a look at our specifications, I'm proud to say that I often get comments, they're some of the most readable technical specifications in the industry. And I'm going to talk a little bit more about that when we do our awards. Also, I should mention, after dinner, we're going to have a little celebration. This is sort of between the games and dinner. Right after dinner, we're going to have, you'll see. We're going to have a little bit of a celebration. Now, switching gears. Oh, I forgot. We have T-shirts celebrating the 20th anniversary of the OSGI Alliance. You'll see people walking around with those. And they also have OSGI socks. They're all at the registration desks, and we have 600 of them. So please pick some up. If you haven't picked it up yet, pick it up, because I got to carry them all back in my suitcase if you don't. So please go get your T-shirt and socks. Now, for the 4th year in a row, switching gears as I said a moment ago, we've been handing out leadership awards, and they recognize individuals or companies that have made significant contributions to the OSGI community. And I'm pleased to announce 2 individuals this year that have made significant contributions over the past year. I'm going to start with somebody here in the audience, Ray Auger. Ray, could you come on up? We're going to do a little experience. Got it? Thanks, Ray. Don't go down. So this man is one of the most energetic people I've ever seen. And the award specifically this year is for something that Ray did to make our specifications more available to the world. For years and years and years, we published in a PDF format. But as you know, search engines don't scan PDFs. You can't just go in a search engine and look something up. And we had a publication pipeline that was kind of difficult to just transform to publish in HTML. Ray, through a superhuman effort, made a high-fidelity version of our specifications available in HTML. So now you get on Google, you get on Bing, you can look stuff up. It's been a big boon to people who are just trying to write some OSGI code and need to look something up quickly. So Ray, thanks again.
No problem. Thanks.
Let's hope the AV gods are good to us here. So my second award goes to Dr. Richard Nicholson. Richard has his PhD in cosmology, but he, for some reason, plays with computers. And he was on our board of directors for years. He's been a treasurer. He's a past president. He was a president before I was, and has served the Alliance in many, many different ways. He's been a staunch advocate of not only the technology, but the organization. He has been out there advocating for us, and Richard actually has received 2 different honorariums this year. One, similar to Ray, is the Leadership Award for what he's done on the board and in his roles there. But the other is a very special award. It's called the OSGI Laureate. He's only the 5th person in our 20 years to get the Laureate Award. It is a lifetime appointment. It's in honor of, basically, it's kind of a lifetime achievement award. And it's well-deserved. The man has done tremendous things. Unfortunately, we found out recently that he couldn't make it here. He was kind enough to record a little video, and I'm going to play it now, if I can.
So sorry I can't be here with you folks this week at the OSGI community event. I'm having a great time there and talking to each other. It's with real privilege that I would like to accept the OSGI Leadership Award. I'll just get it, 2019. I would like to thank the OSGI board and the members for this award. It is, as I said before, a great privilege to have received it. When you believe in something, it's very easy to contribute and to help to drive. And ever since my involvement with the OSGI Alliance in 2006, I've believed deeply in the power that the technology brings to the IT industry, and I think the best days are ahead. So I'd encourage you all to keep pushing those standards, keep contributing to the Alliance, and let's see what the next decade holds. I would also like to thank the Alliance for also awarding me the OSGI Laureate. And this means that I can keep in touch with you folks and hopefully contribute from the sidelines in the stories that goes forwards. So once again, thank you very much to the OSGI Alliance board. Dan, John, it's been a great pleasure working with you all, and all the very best.
Okay. Yeah, it's unfortunate that Richard couldn't be here. I think you'd all love to meet him. Great guy. All right. So, I don't want to stand in the way of our keynote. I'm looking forward to seeing this. This is a colleague of mine from IBM, and we were brainstorming for the Ralph. I'm not going to say it. But let's put it this way. We were looking for an interesting topic, and several of us were brainstorming about this, and I couldn't think of it. Matt came up with the idea of maybe talking about Java in a serverless world, and I thought that was a pretty cool topic. So, Matt Rakowski, IBM, senior technical staff member. Matt, could you come on up? I'll turn it over to Matt.
Hello? It's showing my speaker notes. Now, let's stop here. Let's kill this. How's that? All right, much better. So today is the topic of the intersection of Java and serverless. I'm going to take you through and level set you on what I believe serverless means, its primary use cases, and then talk specifically about how Java fits today and how we have some issues that we're experiencing and what I believe some things we could be looking at specifically in the near term to make it better. I'm speaking with my primarily Apache OpenWhisk hat on. It's a project that I was asked to take from IBM Research and find a home for it, and we did in the Apache Foundation. And we brought it to graduation in over the course of about 2.5, 3 years. And it's a lot of work. Serverless, you think small, but this one had 51 repositories we had to cleanse and license and all sorts of things. So let me go to the next slide. So I thought it would be a good thing to start by talking about my own personal Java serverless journey so you might better understand my perspective as we go through the slides today. So I also call this section a Java developer there and back again. So in terms of the age of serverless, I lived through the early ages as a developer. I had a comfortable life in the Shire, if you will. I call this the age of antiquity for humor's sake, or before Java era. I was a C programmer, did some assembly, and dabbled in C++. Then suddenly, there was an awakening period where Java came along, and I was thrilled because I thought, here's an object-oriented language which came naturally to me. It had a great set of hardened classes APIs that did some really cool stuff. And I guarantee you I tried every class, every API, every method that was available and played in applets, all those things from that time. And I couldn't wait for the next version to come out. And as soon as we had some JDBC stuff, I was like, cool, we can start doing some really cool things with databases and things like that. And then I call the next period, now that my eyes were open, I thought, what's happening next with Java? I call this the age of exploration for Java. So with Java 2, I'm a graphical guy. I love user interfaces, and I thrilled that we had Swing. And I wrote custom controls, and I started using Visual Age for Java about that time. And then when it came time for me to work on a universal service registry called UDI, my team and I decided to do the entire back end in Java, and we did a complete web application using struts. And we actually took that application and migrated it a couple times and adapted it for NTT Docomo and for Microsoft and other companies. So at this point, I thought the future was limitless for Java. I thought we were going to conquer all of the world, or Middle Earth. So I call this the age of exploration. So I went on to do more things with WebSphere Transcoding Publisher. We wrote transcoders that converted document formats. And it was a part of a product. We created plugins for Scalable Effective Graphics 1.0 for browsers to do rendering. I saw 1.4 come out. I view that as a hardening for business. We have security features, we have crypto, things like that. So I thought that we're mature and we could basically reach out and do anything. Around Java 1.5, I encountered OSGI. And I was given a couple devices and said, make these two devices talk together with OSGI using an encryption protocol. So we blew that up into a giant demo that ended up being a broadcast encryption protocol with a back-end web service that was able to share and stream content around smart TVs, tablets, handheld phones at the time, set-top boxes, et cetera. And it actually won Best of Show in its category at the National Associated Broadcaster Trade Show in Las Vegas in 2005. And so the very last thing I personally did with Java as a Java developer, I took the specification for that encryption protocol. I created a reference implementation in Java, handed it off to a bunch of electronics companies. And I last remember having Ganymede installed on my system, and then something happened. A cloud is upon us. Cloud computing came to my doorstep. This is Mount Doom. And I call this the Dark Ages because everything changed and it was no longer Java. So I was asked to look at platform as a service. I became an Azure certified architect. I learned C#. I moved on to OpenStack and I was forced to become a Java programmer, Python programmer, Python 2, Python 3. I worked on many different components there. And that went on. And Java 7 and Java 8 came out, and I was oblivious to it. I thought the cloud had changed everything, and Java had been erased in my life. So a light shineth forth in my life, personally. And I call this the age of rediscovery. And the project I just mentioned earlier, that I'm still working on, and I'm a committee member for, is Apache OpenWhisk. And although the back end was coded in Scala and the front end in Go, I was very pleased to discover that one of the first 4 languages they supported as a serverless platform included Java 8. And so I thought, Java's still there. I'm going to be able to reconnect with Java, and so it really thrilled me. So the Renaissance. So my team since that time has been striving to figure out what we do to upgrade Java, and we support now an OpenJDK runtime. We have a pull request, which I'm getting reviewed for JDK 11, which should go in hopefully a week or two after I'm back from this trip. And we thought, what more can we do? I want Java to be as prevalent on serverless as any language. So first, what is serverless? So first, I've got to thank some marketing person for forcing me to define serverless at every conference and every article I write or every meetup I give. So my personal concise definition is below. It's basically event-driven programming using simple standalone functions with the goal is no deployment or operational considerations whatsoever. So the goal is to take the ops out of DevOps. So your typical developer in the DevOps world, being the highly efficient live pipeline of code to production, has to worry about many things now, and it's a pain point. They have the DevOps blues. So all they really do is they just want to code. So serverless, as acknowledged, is a misnomer. Servers do exist. It's that they're hidden from the developers. They're not the developers' concern. Their configuration, their memory, all those things. It approaches no ops. So the goal is no ops. And in terms of a good platform and a platform provider, they should minimize these things to very, very minimalistic configuration sets. It's the provider's job to do all heavy lifting. They have to provide the maximize utilization, the CPU, the memory, make the networking efficient, guarantee performance, scaling, scale out, high availability, and all those things, in accordance to whatever they agreed with you against their license agreement. In terms of what we want to achieve for the developer then is we want them to focus on implementing app and business logic, getting their job done, taking data and connecting it to a target service or a web interface, getting it to the consumer or the customer quickly. We want them to be able to take functions and compose them in sequences or workflows quite easily through these simple naming conventions. And a developer is always happy when they go to build and all of their tests pass and they're able to have their code merge in system. That's the goal, is have people just to write their code, get their function working, and it does their job for the day and they're done. If we look at serverless, what I call the lowest common denominator programming model, at one end it starts with an event. And we basically represent that event programmatically as something called a resource called an event source. And it provides a feed of normalized events through the system. Conceptually, there's always something called a trigger. Sometimes it's substantive and has a queue behind it. Sometimes it's just a logical name. But that basically is a point where people often have some normalization of data between the event source and the target function. And so it's the job of the trigger to then be connected to a function which reacts to the normalized data. In terms of serverless workloads, it typically spans, when you're dealing with serverless, you're dealing with functions, but when you go to deploy them, it typically spans both containers as a service as well as functions as a service. I threw in pseudo-serverless because there are many people who do serverless type things or have similar type of architectures, but they don't generally offer you, though, a general deployment model where you can, and a management API where you can have a choice. Typically, even one of our own partners, Adobe, at Apache, who's a fabulous contributor, they don't have a general serverless platform. They use OpenOS and they couple it with a very specific API, Adobe I/O service, and you'll be able to write Node.js functions, and it's managed by the Apache serverless backend, but you can't upload containers, you can't upload general functions and have them scale out for whatever purpose you want. Why serverless? Agility. We kind of covered that as well. If you don't have to do the ops, you're agile. Scaling is automated. Again, covered. In terms of scaling, serverless is great because you don't have to worry about spikes in requests, spikes in demand for your services. The system is always smart enough to detect the rate of incoming requests and scale from 0 to n number of instances and back down again when no more requests come in. It's great if you're unsure of your intermittent workloads, intermittent requests in your workloads, so you don't have to think about what's my maximum, what's my minimum, how much memory should I support, concurrency, all that's figured out for you. Cost reduction. Typically, we say the model for serverless is pay-as-you-go, pay-go. It costs fractions, 0.0000 pennies or cents for each request, typically. You can have fixed price options. In fact, I looked last night to see what it changes. Good for you all. All the serverless providers are competing actively to be the lowest cost provider for serverless functions, hosting provider. For example, I know on Lambda, and it's true as well for IBM's Cloud Functions, which runs on Apache OpenWhisk, that the standard free tier, you can run 3 million requests per month at 512 megabytes memory, and the function runs 1 second, and it comes out to $18 US. In fact, if you have the free tier, that first $20 is effectively free. I've spoken to, at meetups in my town of Austin, where I live, of some startup companies who love this because it's risk-free. They can have a plan where they know they have a very large block of requests, and it's a fixed price model. They're not guessing what their prices are typically. As long as they understand when they're writing their functions, they actually configure them for specific memory, and there they go. What can serverless be used for? And basically, I say any event, anytime, anywhere, anything in the physical world can be turned into a digital event that can be an event feed that triggers a function. And so I'm going to cover, I have many more use cases, but I have 4 here. The typical entry point for serverless is doing something, is batch processing. So you've got a legacy system. You have something called an alarm feed or something synonymous to that in your system, and it's part of the serverless platform. You're able to configure cron jobs, basically, that run at specific times or time intervals. In fact, they can create time windows with them, as well as run specific, even one-off events. There's a great story of actually a German music festival who hosted their web service applications using serverless and had a one-time event that deployed their applications when the festival started and ran the applications, and had another event run when the festival ended and undeployed all the applications when it was over. Very cool. The #1 use case, in my opinion, for serverless is API management. So you have a function, it has some internal logical name, very simple to develop and remember. It works inside of a logical namespace. And you can map it through an API gate-like service to the real world using a public or private URL. And you typically map things through HTTP REST verbiage. Typically, even in addition to an alarm triggered function or a function triggered otherwise, you're typically doing some type of data transformation. Very typical ETL pipelines. You're taking some source data, whether it be data at rest in a database, data coming off a message queue someplace, or even live streaming data, and you associate that with a function that takes that data and prepares that for a target source for display purposes, and it actually can work with an analytics service as part of that and call it and do some intelligent tagging or views on the data. In fact, we're very excited we have TensorFlow, for example, which does in pipe queue streaming or analytics, and you can assign to your TensorFlow thing a serverless function to execute as data is coming through a live pipeline. This is great for IoT sensor data. It's great for financial market data, anything that is live stream, even log data. The last use case, which has been big this year, because serverless providers can make lots of money of it, is this idea of handling embarrassingly parallel tasks. Basically divide and conquer. Take a large data set, divide it into small data sets. Each function can logically process. Those functions then agree on where to sync up the data someplace once all the parallel tasks are completed with the analytic results for them. MapReduce, Monte Carlo simulations, and anything you can do in the analytics space is now being done with serverless. It was ironic that a year and a half ago, I was at ApacheCon showing our project as a newer project, and I had a booth next to me for Apache Spark. And I talked to them at length since we had some downtime at the conference, and I'm like, what prevents our serverless platform from taking your Jupyter notebooks that have a function inside of it and running them on our serverless? And they said nothing. And guess what's happened? That's exactly what's happened. We're called the poor man's Apache Spark, but it's fabulous for developers and users. You have access potentially to, even on our free tier, 1,000 concurrent nodes to number crunch and analyze data. It's at fractions of the cost of what might cost you on a Spark dedicated cluster or something. So I wanted to take you through how we spot a good serverless platform. I could show you OpenWhisk and take you through the parts of it or some other platform, but I thought we'd quickly go through a top 10 list, and I'll try to have you understand why these things, each one is important. In terms of number one, if you want to work with a service platform, make sure it has a good home. And as Java developers, we're all aware of licensing issues and compliance and having a good home. You guys have a great foundations you work with, and you should look to work with serverless technologies that are equally housed and governed in an open way with processes and things to ensure your contributions are meaningful. With security, bug fixing, all those things as well. Consistent set of REST APIs. This might sound funny, but when Apache graduated, I was preparing for some interviews to get some articles, and I went back a year in time, so about end of August last year. There were some articles written about the top 8 open service platforms, and of those 8, 4 are clearly gone, dead, deleted. 2 are probably struggling and probably may have died already, and so only a couple of them are left besides Apache OpenWhisk. And so we've had the longevity and the programming model and all these things figured out to a degree where we have a very good set of management and data APIs. Management APIs to manage your functions, manage their artifacts and metadata, as well as invoke them as a user, as a programmatic application. And avoid API churn. So there's some really potentially good open source service projects. My teamwork does not restrict it to OpenWhisk. I do other things besides OpenWhisk, and I'm trying to figure out always what technologies we need to work with for openness, or maybe support more technologies in OpenWhisk for different use cases. And we see a lot of API churn, especially when they haven't figured out their resource model. They haven't figured out we need a trigger and something called a feed and things like that. And we see a lot of API churn. Supports deploying functions in containers. So we talked about the 2 deployment models. A good provider does not restrict you to just functions. The reality is that we want people to move existing workloads, and to do that through lift and shift, we need to support general containers that they can scale up and scale down against some runtime contract. The Java community has excelled at championing microservices and version control, dependency injection, all these things, and you've adopted, probably lots of you, different frameworks from Eclipse Microprofile to others. So you understand the drive towards containers, and I've heard a lot about containers visiting the booths today. Develop in a container, or do these things in a container. If you're doing those things, you're on the path to serverless very easily. And we try to help you. So any good serverless platform has what's called a source-to-image solution, a set of tools to take your source code against a language runtime and a set of libraries, and is able to give you some automation to package them towards a finished container that will run on their platform. But the most important thing, as this audience, I think, would agree, is to make sure Java supports the first-class citizen. Again, I was proud Apache supported Java from day one. Not surprising since it came from IBM, but still, I go to serverless providers, even providers that are in existence. Their Java support is basically, oh, we got a JDQ running and runtime and we're good. That's not good enough. The tooling, the data models, the data descriptors, the schema, those things should be considered for workflow design, coordination, data coordination, those things. And I have some challenges I talk about later on about that. Scaling horizontally. I think it's important to know that it's not just about scaling containers and scaling from 0 to n. It's about making it extremely efficient. So there's some concepts that you won't see in all platforms. So you're paying for the amount of time your function runs. So that means if you're starting up a container with a big fat container with a big fat application, every time it scales, you're being charged for that startup time. So what Apache OpenWhisk and other services have these terms called stem cells. So they have pre-configured pools or clusters, and they're stem cells because they're language independent, and they have images ready to go cached on each of the clusters that's immediately able to be injected into the system to make them warm containers. In fact, we can host pools of Java, pools of Python, pools of whatever at different levels or different profiles with different libraries, and have them ready to go. So all we need to inject is the function. So you don't pay for the cold start times at all. You pay for just the time for us to load your jar file into the image. And that's important to look for, because you're paying for that cold start time. And then warm containers, the system has to have some intelligent scheduling to know that we already have a specific function that's already running and warm in a certain container, and we can keep sending requests to that container as long as it's finished its previous data processing workload. So these are things to look for in a good serverless platform. API functionality, we talked about that a lot as a primary use case, number one use case. You should look for things though. Does it offer you the control you need in terms of security, in terms of being able to supply open API Swagger documents to configure those public endpoints, private endpoints? Does it support CORS header? If you're doing data transformation and you're going to send that to a website, maybe you'd like to have the output of your function to be directly accessible and publish HTTP MIME content directly to a website through cross-origin resource scripting. Rate limiting. If you know your function is doing something data intensive or you don't want it to be spammed or you're concerned about that, you can limit the rate at which these functions are called. And of course, all these should have analytics at the API level, the public to know which things are being called and how they respond to the end user, and are available also for throughout the DevOps lifecycle, developer endpoints, testing endpoints, and production endpoints at different version levels. Now, many cloud providers saying, yeah, I can scale you out, maybe they have all these other things, but when it comes down to it, you need a data source and also perhaps a place to send the data once you're done processing the function. So good platform providers give you a robust set of data sources, event sources, to bring data in from that follow the no-ops principle, that follow the serverless principle, and that all you have to do is simply configure your client, your Kafka client, your database client to your function and provide maybe some credentials that are secured by the service platform, and connectivity should just be through logical naming. That's what you should be looking for. Integrated logging metrics. Dan said, emphasize that last thing on the first slide. It's done for you. You should not have to provide any inline logging or metrics or think about that at all. If a service platform is asking you to embed this stuff in your code or write some special stuff, that's not what your function should be. You shouldn't be spending CPU time and load time and library memory time loading, logging, and tracing and all those things. With containers, we have some very good ways and conventions to do that for you. And we can provide you great, very granular metrics. We should be able to tell you end-to-end where you're spending your most time. Under a load, if you have outliers, some requests take long, we should be able to immediately tell you what data was sent to your function that caused it to spike, those type of things. And 10, compositions. Now this is very rare among service providers. Most are still version 1. They haven't thought about through the programming models I alluded to earlier and how you're able to compose your functions. So you actually can do simple sequences. It's a great starting point. You do a lot with those things. So one piece of data to another, chain it out. And they're always interacting, hopefully, with RESTful services. You don't want, if you're paying for time and function, you don't want that function doing live connections to a database. What you want to do is somehow offload it to a service or have something that does that for you. And what's important to note is you can have heterogeneous compositions. So let's say you encounter a Python script that does some really cool analytics on some data, and maybe you can include that in your pipeline. Again, the inputs and outputs are all data-centric. data type centric, typically JSON or raw HTTP data, and you can do some compositions across languages. And the state is managed for you. The goal is if you do provide compositions, that state is all managed for you. In fact, in OpenWhisk, a sequence is considered one function. So in terms of a charge model, even though you're calling 3 functions as part of a sequence, you're only charged for 1 request and the end time for 1. So of course, I'd love to say, Apache OpenWhisk has all these things. We strive to have all these things. We have a lot of these event integrations. A lot of them are experimental simply because there are so many. I mentioned that we have 51 repos, and we have 51 repos because of these things, because we have so many event sources, and we support so many language at different version levels. It's hard to keep up. But I'm very proud that just a month ago, and this had through serendipitous events, one of our partners said, hey, we need an easy way to run OpenWhisk on the developer side. So we actually packaged all of OpenWhisk into a single jar file. And so you can actually run on your desktop all the entire OpenWhisk control plane, data plane, management plane from a single jar file and do testing and development locally against it if you'd like. And in fact, a company has contributed 2 weeks ago what we call Playground, which is an in-browser app that will connect to that jar file and interact with it and allow you to write functions in any of our languages and compose your JSON inputs or provide links to your raw data inputs and run it through the system and get your outputs. So it's pretty cool that you can do this, run this entire thing, and it scales. This thing runs on thousands and thousands of clusters and has for 3 years now in IBM Cloud and also partner clouds in our project. So advancing serverless and open. This is kind of the start of the way forward. So serverless is the ultimate microservice framework. If you're going to microservices and you're still tied to lots of frameworks and you're still worrying about all these things some of the things I've talked about, some of the operational concerns, maybe you should look to serverless. If you're there, you're basically there if you've gone to microservices. Look to take the next step. Now this next slide, I worried about this because it dates me. So if you recognize this picture, I added the word Dune, and because I wanted to channel the protagonist. So that's Paul Atreides, and he would say, Java must flow in serverless. That's my belief. That's my call to you to say that as a serverless or as a Java community, serverless is looking for your input. I want to see more Java functions and more activity in some of our open source communities for tooling and for things like that. Today's challenges: script languages dominate. Basically, the first language was Node.js, JavaScript, as embodied by Amazon Lambda. And the perception is that script languages are really fast, and they are. And Python is all script language, and that took off for AI. And anecdotally, even where Java and other languages are available, as with OpenWhisk, on any given day, 90% of the entire platform workload, 90% are JavaScript functions. That's probably on the low side, maybe as high as 94, 95%. And so 5%, 3 to 5% is Python, and it's increasing because of those AI workloads. And then the rest of the language, including Java, is the other 5%. We're in the other part of the pie. And I want to change that. That's why I want to think about more how we can do that today. So in terms of client-side issues, we have to worry about fat jars. So in terms of packaging your app, a lot of these microservices, if you want to, and the goal here is also functions as service. We don't want you to load and scale containers. Scaling and loading containers and working with container as an artifact does not make sense. You should be able to use jar files and try to squeeze them be as thin as possible and make your uploads and management of them and thereby scaling of them very efficient. In terms of tooling, I think there's some things we can do. We'll talk on the next slides what I think some of the ways forward are in terms of these technologies. So, I've even seen people trying to package an entire microservice application, multi-resource, multi-bean, with like a complete framework and throwing every library, but these containers become 1 gigabyte in size. You're not going to scale efficiently and take advantage of serverless with that. You need to do it through a function level. That should be your goal. On the server side, it's cold start times. It's all about saving you money because the scaling factor. You don't want to suffer cold start times because you're paying for that. And the problem is that on CAS, these containers are very bland and made for a general use case. So we have to figure out how the client-side jar files are created, somehow are coordinated with definitions of these server-side runtimes and be able to coordinate what libraries and what things we need in the server side so we can guarantee produce thin jars. So what things have I looked at? I encourage us to work on the problems together in open source communities, not just Apache OpenWhisk, but others. I'm going to reference one in the next slide. But we need to produce use case specific profiles. It would be great if our Java communities would agree on different profiles for task-specific functions. For example, Python, you'll see in the Python space that Python has different runtimes that include different AI libraries, ready-made for a lot of these Monte Carlo or other types of genome use cases. I'd love to see formalization of those profiles so we can actually have warm pools, clusters of many, many containers able to run workloads specific to AI or specific to image processing. And we need to know what those look like. We also want to understand how we can take existing profiles and keep them up to date with base runtime images and include the right libraries with those, how we create a formal definition for those things. In terms of quick start, I'd love to see Maven quick start, Gradle, plugin support, et cetera, targeted towards serverless, targeted towards these source to image pipelines or pipelines that produce both a profiled image that can be pre-warmed that matches a jar file that we know can scale very quickly. Source to image I just mentioned, bringing them together. Annotation mapping. So this is the most confusing thing I found coming back to this Java world. JAX-RS made sense to me. I can map everything you use annotations for JAX-RS and to serverless. They can map to serverless configurations. They map to an API configuring an endpoint, naming an endpoint, its pathing, etc. But as soon as I shift my attention to Spring or something like that, I was like, oh my gosh, look at all these custom annotations. What do we do with them? And so I'd love to have a formalized way against a given target to understand how we translate these annotations for these different profiles to serverless configurations in an automated fashion. ORM, as I mentioned, it would be great to figure out how we break apart Java application workflows. So there's always a data target or data source that we interact with, hopefully through REST calls. I think it would be great if we had a concept of a standard library of functions to be used in compositions or sequences that would work through ORM to databases. So have the REST interfaces implemented as functional service APIs, basically, that are stateless to the workflow. So they offload the reads, writes, and those things. In terms of strong typing and related to ORM a little bit, is everything in serverless is 99% of it is JSON, or very very high percentage is JSON as input, and either some raw data or JSON as output. I'd like to change that. And if we start migrating some of our business applications, I'd love to have input and output have schema. And this has been a goal of mine for years on the OpenWhisk project, is try and expand the notion of strong typing. I don't see, my concern for serverless is that when we're especially in compositions, we're composing these things together, large applications, there's no way for tooling and things to say this function is compatible with this function because they have the same data types, data schema. So I'd love to have the Java community influence those things, bring us to use cases in the open source communities, to Apache, et cetera, to force us to confront those use cases. So I've been trying to figure out how we bring this all together. So there's another project called Tekton, which was spawned from a Knative build project. It's now under the Continuous Delivery Foundation, which is under Linux Foundation. And what I foresee is defining, maybe in conjunction with Maven and Gradle and having those as part of the tool set, a consistent set of steps we go through for building Java images that support both containers as a service and function as a service. If we go left to right numerically, We can start with a pipeline that has the source image someplace of your application serverless, and it maybe has a POM file or something like that, and this pipeline can automatically point to that GitHub repo, detect the tooling needed, and install the tooling and at the start of the build pipeline as a pipeline resource, that your code is a resource. Bring it in, build it, and at that point, optionally, send it someplace of your choice. Send it back to your desktop or send it to a repository, publish it someplace. But could keep going. If you want to, it then could take that and you can specify the runtime you would actually want to create a container for to run a container as a service platform, serverless platform. And actually during that phase, you could actually say, I want this profile. It would install the libraries needed for that profile. It would look at annotations, look to automatically configure your stuff. I didn't include that numerically, but there's a lot of things we can do in the middle of this that are not there yet. But in terms, and also create profiles. If we define an image library, a 3D image library, processing something, reduction library or something, or a analytic library of some kind, a series of libraries, we could define those as some profile. And then we can actually define what that profile is, run a set of tests against that profile and the JVM, and capture the shared class cache. So we can create and bake that into the final image and maybe push that out. So that's your profiled image stored that now we can put on the serverless platform and scale out. They have for these pre-warm containers, so you only have to write your thin functions. And that's the goal. That's what we show here is we can actually then also, if you want to have a dedicated container, we can keep going and bake your function into that runtime for our target platform, for OpenWest, for Knative, for Lambda, for wherever, and we finalize image against the runtime contract, the endpoint, and things like that for that target platform. So my team, I say team, but it's basically 1.5 people, and myself, probably is another half a person, shared this vision with my team back in June. And they worked diligently through the summer on the Tekton project, which is a great community, one of the friendliest ones I've encountered in the past 4 or 5 years. And we had to enable a lot of this complex. This is the most complex pipeline that they've ever seen. We had to write a lot of code to just enable this. And my team over the past 2-3 weeks actually was able to realize this pipeline. So it's basically at each point 1, 2, 3, we created standard specification YAML files and things like that at each step to configure the steps. And I'd like to show it to you if I can. I think I got to wander up here and manually hit. Oh, is it playing? No. So I'm going to stop there really fast. So this is going to be running. So Tekton pipeline is running on Kubernetes service. We've hidden all the boring Kubernetes API command line stuff from you, but I just want to show you some of the steps that go through. So basically, what we've done is we've installed some of the credentials we need to access GitHub source files and image repositories. We've gone through and established the pipelines consists of tasks. You'll remember my diagram had 4 tasks. It creates those 4 tasks, and then it configures the entire pipeline and all the parameters it needs for all the tasks in what's called a pipeline run. That's your instance document. So when we run the pipeline, if we can wake up here. So if we run the pipeline. So we're going through is a Tekton dashboard, and this is my team. We're showing, we instituted this dashboard. There was a newer dashboard we couldn't get working, but there's a new dashboard we hope to get working soon, which is more graphical. But basically, as soon as we load all the tasks, it starts doing these things. So you're seeing the green, each of the tasks go green and the steps inside the task being run. You see the logging to the right of what the tasks are doing within the containers. It's basically a chain container approach where each output of each task is passed to the next container who does the next step of the build. So these containers can be broken apart and do very granular things. Right now we have one container that does a lot of things Java relative in terms of profiles and frameworks, but we can break those things apart. And these are the things I want to work with you all on as a community to figure out how we codify and define these steps that works for everybody. So then it's actually going from 1 to 7 on my numeric chart. So now it's actually building the final application. In this case, we're baking in the jar file. We've actually profiled the function and a set of tests have been run through the JVM. We've saved the shared class cache, and now we're actually running the function. So I'm going to pause here. So side note, so my half developer was a part-time developer who's trying to become full-time, who's never coded in Java. Literally, swear to you, literally 2 weeks ago, he had never touched Java or seen Java before. So he wrote a function, and I spent a half day with him talking through Maven and gave him a sample app and showed him how to do a quick start. And he was able to write this function, which basically takes a color image and transforms it to a black and white image through a serverless endpoint very quickly. So, and it's a great story. He didn't have to know anything about the pipeline. He knew nothing about the pipeline at all. All he knew is he had to write a function that did this. And suddenly, this container is automatically deployed to, we actually deployed this to Knative, by the way. So we're actually running this container in a Knative service running on Kubernetes. And so this is a great story. This is exactly what we wanted, and it was kind of luck. I got a new developer. I didn't plan for this. And he was able to do the complete no-ops approach. So I think it's a great story. So in conclusion, what's next? You've heard me many times today talking through, I want to work with the community, I need Java to flow into serverless, especially in open source communities, and I'm serious about that. In terms of Java, Java is the master. It has won the battle in the kingdoms from manufacturing to finance to everything. Basically, you have the power. You own all the valuable transactions and data and bringing them to web front ends, to microservices, and cloud providers who provide service platforms are waking up to that. They're waking up slowly. They understand they need to get you on serverless, but they're still trying to get you on containers and do those things. But they really are not Java first. They're basically saying lift and shift and we're done. So I think we can do better than that. I think the community has enough weight and leverage to really shape what Java serverless becomes in terms of Java. So what I want you to do as a community is to contribute, lead, and claim the serverless throne. I'd love to be able to come back next year, maybe not as a speaker, but just talk to you all and be able to say, hey, we're in our cloud, Java's now 10%. It's a modest goal. But I think that if we work through these open source projects and create compelling use cases and bring them to these communities and do things with ORM and data schemas and do some interesting compositions, we can achieve that, and we can start working then on improving these pipelines and tooling. And I have greater goals. I've talked to people at this conference in terms of Che and in terms of CodeWin and things like that, of taking these pipelines and figuring out how we make this all fit together in the open. And I think that, from my point of view, and I've expressed this to people here at different booths and whatever, that I think Tekton is a great place for us to collaborate no matter where we're at in that pipeline, whatever our concern is. There's a place for you to say, hey, I'm a specialist in creating this part or JVMs. You can help us figure out how to formalize this and make these pipelines universal. So I think that would be really cool. So that's all I had today. So thank you.